Greetings, this is Mr. Garwood with our continuing series on calculus, second edition by Briggs, Cochran, and Gillette. Today's lesson comes from section 2.3, techniques for computing limits, and we're looking at solving for a variable such that the limit exists. So our example for this video is for f of x equals the piecewise function where negative 2x plus b is the rule if x is less than or equal to 2, and the rule is 3x plus 5 if x is greater than 2. We want to find b such that the limit of x goes to 2 of f of x is some value L. I don't know what L is, but we're going to solve for that value. Now, I want to go back to our definition of limits and the existence of a limit at a particular point. We say that the limit as x goes to 2 of f of x exists if the limit of x as x goes to 2 from the left of f of x is precisely the same as the limit as x goes to 2 from the right of f of x. So really what we're trying to do is we're trying to solve for b so that the limit from the left is exactly the same as the limit from the right. For us to do that, we've got to figure out what we know and what we're trying to find. So my first question is do we know from the left or from the right? For x is greater than 2, I know this value. I'm just going to have to plug in for 2. And from the left, I don't know it because that's where the b is. So I'm going to start by solving from the right. So the limit as x goes to 2 from the right of f of x is, well, I'm just going to plug in for 2, so 3 times 2 plus 5, or 11. Now this is where I guess we could say things get tricky. What I need for this to be true, this limit, the limit as x goes to 2 from the left of f of x has to be 11. If that's 11, then these two things are the same and the limit exists. So that means that negative 2 times 2 plus b equals 11. Negative 2 times 2 is negative 4, so I'm going to bring this 11 down. Negative 4 plus b has to be 11. If I add 4 to both sides, b must be 15. So, if b is 15, we can say f of x equals negative 2x plus 15 if x is less than or equal to 2, and 3x plus 5 if x is greater than 2. And if that is true, then the limit as x goes to 2 without regard for direction is 11. So the key idea here is solve for the one that you can, work backwards, make sure the two limits are the same. So here's the critical thing. We said, all right, this is 11. And if this limit is 11, for this to exist, that has to equal 11 as well. And we solve from there. Hope you found this interesting. Hope you found this useful, and I look forward to seeing you in the next video.